Hey guys, welcome to week 4. We're going to jump into astronomy, but before we do, I just want to make a quick little side note. I miss teaching you guys. I hope to have you in class next fall because this is okay, but it's definitely no substitute for trying to teach and trying to help you learn while being there with you. Anyway, on to business. Our solar system is looking something like what I've drawn here. Now, this is not accurate in terms of scale just because it should be way more spread out than this, especially these larger planets here, and this Kuiper belt should be way, way further out. But this is as big as my whiteboard is, so we're going to make it work. First thing I want you to notice, close to the sun, we have 4... Whoa, moving my board, that's no good. 4 inner planets. And those inner planets are all fairly small. They are rocky, similar to Earth. They have a solid surface you can stand on. And again, they're all fairly close to the sun, so they're kind of warm. Out beyond the inner planets, you have the asteroid belt, which again is composed of asteroids, and we'll talk about those in a few minutes. And then out here you have 4 outer planets, which are large and gassy, and as you can see, they all have rings. Now, the only one you can see the rings from Earth, it would be Saturn, this guy right here. But the other 3 have rings. You just can't see them unless you're actually there. We've had space probes arrive at each of these planets and take pictures, so we know they have rings. You just can't see them from Earth. Out beyond Neptune, we have what's called the Kuiper belt, which is kind of like the asteroid belt, but as you'll notice, it's really, really, really big, and it goes way deeper than this. I just ran out of whiteboard here. So, asteroid belt, Kuiper belt. Okay. That being said, let's just kind of buzz through this. These inner planets also are called terrestrial planets. Terrestrial means Earth-like, and like I said, they have a rocky surface similar to Earth. They have warmish temperatures because they're kind of close to the sun, so that makes them somewhat Earth-like. These planets out here are called Jovian planets. Jovian just means gas giant, so they are large, and they're mostly made of gas. If they have a solid surface, which we think they probably do, it's way, way, way down in at the core in places where we can't reach because the pressure is too great. So, for the most part, they're made up of gas, mostly hydrogen and helium. Like I said, the asteroid belt is right up here, and it's fairly small compared to the Kuiper belt. The asteroid belt is composed of asteroids, which are mostly rock with some patches of ice. Sometimes that ice is water ice, sometimes it's carbon dioxide, sometimes it's other gases that have been frozen. So when we say ice, it doesn't necessarily mean water, but it can. So again, asteroid belt, mostly rock, a little bit of ice. If you jump out to the Kuiper belt, we're way further from the sun. And so these objects that I've drawn, you can kind of think of it like the asteroid belt, but these objects, instead of being mostly rock, are actually mostly ice with chunks of rock embedded in it. Okay, now there's lots of variation out there, but for the most part, these guys are ice with rocks embedded in it, and the asteroid belt was rocks with patches of ice, if that makes sense. So, again, here's our layout. We have inner planets that are terrestrial, outer planets that are Jovian. The asteroid belt separates those two. The Kuiper belt is out here beyond the orbit of Neptune. And the last thing I want to mention on this video is the planets in general. I've got 4 here, Mercury, Venus, Earth, and Mars. 4 here, Jupiter, Saturn, Uranus, and Neptune, which, side note, Uranus is totally tipped on its side and it spins this way, which is kind of cool. The rest of them are not. And side note number 2, it's actually pronounced Uranus, not Uranus, which I know Uranus is a whole lot funnier, but I would like you to know that it's actually pronounced Uranus. So, anyway, done with the side notes. You'll notice I have a green dot here, green dot, green dot, green dot, green dot. That corresponds to your dwarf planets. Now, dwarf planets are those that are not massive enough, which, by the way, when an object has mass, that gives it gravity. So these guys don't have enough mass to produce enough gravity to pull in the objects in their orbital path. So what that means is, let's take Earth. As Earth goes around the sun, how many rocks and asteroids are in its way? None. That's because in its past, Earth has already pulled in all of those objects because of its gravity. This green object right here is Ceres, C-E-R-E-S. It is one of the 5 dwarf planets. It's huge for an asteroid, but it doesn't have enough gravity to draw in all the other asteroids in its path. Therefore, it's a dwarf planet. Saturn's a major planet. Why? Because it has a clear orbital path. Pluto, you'll notice Pluto is in a belt. That means it does not have a clear orbital path. Dwarf planet. Haumea, Makemake, dwarf planets. Eris, dwarf planet. So in a nutshell, dwarf planets haven't cleared their orbital path, so that means they're in a belt. Okay? So anyway, there's video number 1. Okay, in our explanation of the solar system, again, I'm not going to spend much time talking about the planets because you've already learned about those. I want to focus on some other things. This video, I'm going to talk about comets. Comets are often described as dirty snowballs, which basically means, imagine you go outside at the end of winter and try and scrape up that last little bit of snow off the ground. Okay, if you've ever done this, you're cramming it together, but you got to dig right off the ground, so you're ending up with chunks of rock and dirt and grass and stuff in it, right? And so you could make a snowball, but it's definitely going to be filled with debris. It's going to be filled with rocks and dirt. Okay, now a comet is like that, just a whole lot bigger. It's mostly ice with chunks of rock and dirt and pebbles and grains of sand embedded in it. Now, these chunks of ice orbit around the sun. So, as you can see, my short period comet here is this orangish line, and it's coming from not the asteroid belt, but the Kuiper belt. And it comes from the Kuiper belt and zooms around the sun and then back. Now, a short period comet has a path that takes 200 years or less. Now, some of them orbit around the sun as fast as 5 years. Remember, the Kuiper belt is fairly big, so if they're coming from way out here, some of those take up to 200 years. Now, probably the most famous comet of the short period comets is Halley's Comet. Halley's Comet comes around every 76 years or so, and it's very predictable. Most cultures on Earth have seen it, they've written about it, they've had stories about it passed on from generation to generation. We have record of Halley's Comet for the last 2,000 years. So, every year at this time in class, I always give this challenge to my students. I give them a long-term assignment. I just don't want you guys to be the exception here. So, I'm going to give you the assignment as well. Halley's Comet is going to come around again in the year 2062, I believe. And you may have to look this up. Usually we do the math in class, but I'm going to do it off the top of my head. Now, 2062 is quite a ways away. So, you're probably going to have to punch this in your phone, put it in your calendar, mark the date, put an appointment on it, do what you got to do. I want you guys to come find me on my birthday, July 10th, 2062. I'm pretty sure somewhere right around then is when Halley's Comet's going to be visible from Earth. I would like you guys to see Halley's Comet. I would like to see Halley's Comet with you. So, your job is to look me up, find me. If it's not in July, come find me anyway. We won't celebrate my birthday. Instead, we'll just go comet watching. And we're all going to go out and watch Halley's Comet together. So, I don't know what kind of social media we'll have in, 2062, but I bet you'll be able to find me somewhere. Hopefully, I'll be able to remember a few of you, but I might be old and senile by then. I think I'll be like 89 or something. So, anyway, there's your assignment. Come find me. We're going comet watching. Anyway, back to important stuff. Short-term comets come from the Kuiper belt around the sun. Now, you'll notice the asteroid belt forms kind of a circle, right? The planets, as they go around the sun, also have circular orbits. My comet absolutely does not have a circular orbit. It is much more elliptical in shape. Okay, back up a step. Planets' orbits are not exactly circular. They are elliptical, but they look circular because they're really, really close. Anyway, comet's path, elliptical. You'll notice my long-term comet's path is even more elliptical, and as a result, it gets even closer to the sun. So, short-term comets come from the Kuiper belt, and they have this elliptical path. Long-term comets go so far away we can't see them. They stop reflecting sunlight way out, here somewhere. But using math, we can calculate its trajectory, how far out it's going. And the weird thing about long-term comets is they don't all come in where the planets are. Sometimes they come from above, sometimes they come from below, sometimes they come from the side. So what that tells us is there's a place out, it's like 6 times further than Pluto, and we haven't ever seen it, but we know the comets are coming from somewhere. So we call this place the Oort cloud, O-O-R-T. And what it is, it's a sphere. So surrounding our solar system is a sphere of these frozen objects, and they come zooming in around the sun, and it takes them thousands of years to get to the sun and then back out to the Oort cloud. Last but not least, objects in space. Sometimes when you're outside at night, you'll see a shooting star. Now, a shooting star is not actually a star. It has absolutely nothing to do with a star. It actually is probably a grain of sand or a piece of rock floating in space. Now, if Earth happens to get close to this object, this piece of dirt, this piece of rock, it pulls it in by its gravity. When Earth's gravity pulls it in, that particle runs into the Earth's atmosphere, which is moving at thousands of miles an hour. That creates friction. That makes the rock get so hot it starts to burn up, and then it burns up in an instant, and you see it across the sky. You call it a shooting star. The actual name for it is a meteor. And in reality, a meteor or a shooting star is generally just a grain of sand or a piece of rock burning up in our atmosphere. Now, sometimes we have things called meteor showers, which are kind of cool because there's lots of meteors coming every hour from the same part of the night sky. So you can look in one direction and just see, 10 of them an hour, 15, 20 of them an hour, all from the same location. So a meteor shower has something to do with comets. So let's take this guy. As this guy gets close, gets in about where Jupiter is, it starts to get visible. Once it gets in past the asteroid belt, it starts to melt. Once it starts to melt, the ice melts away, and any rock that was encased in that part of the ice gets left behind. So now my comet's leaving a trail of rocks and dirt and sand. And when Earth, traveling around the sun, gets close to that path every single year at the same time, its gravity pulls in all of those particles that are in the space and burns them up. And so you see a bunch of them in the same part, the same time of year, every single year. And that's what's called a meteor shower. So every time you hear in the news, oh, there's a meteor shower tonight, you know we're close to the path of a comet that's gone by. And it left behind a trail of dirt and dust. And that is a really short version of comets.